Certainly. Here's an informative tutorial on how to write Python code in C++ without code examples. Integrating Python with C++, a guide. Introduction. Python is a powerful and versatile language, but there are times when you might want to leverage the performance and low-level capabilities of C or C++ for certain parts of your application. Integrating Python with C++ allows you to combine the best features of both languages, Python's ease of use and C++'s speed and efficiency. This tutorial will guide you through the essential concepts and techniques for writing Python code in C++. Understanding the basics. How on Python C API. The Python C API provides functions and macros to interface with the Python interpreter. This API allows you to execute Python code, manipulate Python objects, and handle errors from C++ code. Understanding the API is crucial for integrating Python into C++ projects. 2. Python.h header file. To use the Python C API, you need to include the python.h header file in your C++ code. This header defines the necessary functions and structures for interacting with the Python interpreter. 3. Embedding Python in C++. Embedding involves running Python code within a C++ application. You can initialize the Python interpreter, execute Python scripts or commands, and interact with Python objects from your C++ code. 4. Extending Python with C++. Extending means adding C++ functionality to Python. This typically involves writing C++ code that defines new functions, classes, or modules that can be used directly from Python scripts. Steps to write Python code in C++. Initialize the Python interpreter. Before you can run Python code, you need to initialize the Python interpreter in your C++ application. This is typically done using the py-initialize function. Run Python code. Once the interpreter is initialized, you can execute Python code using functions such as py-run-simplestring, or by using the Python API to call specific Python functions or scripts. 3. Handle Python objects. When interacting with Python objects, you need to understand the Python Object API. This includes managing reference counts, converting between Python and C++ data types, and handling errors. 4. Finalize the Python interpreter. After completing your interaction with Python, it is essential to finalize the interpreter using the py-finalize function. This ensures that all resources are properly released. 5. Compile and link. To compile and link your C++ code with Python, you need to set up your build environment to include the Python headers and link against the Python library. This may involve configuring your compiler and linker settings. Common use cases. 1. Performance optimization. For performance-critical sections of code, you can implement algorithms in C++ and call them from Python, achieving faster execution compared to pure Python code. 2. Legacy code integration. If you have existing C++ libraries or codebases, you can create Python bindings to make them accessible from Python scripts. 3. Custom Python extensions. Develop custom Python modules or extensions to provide additional functionality or integrate with external systems. Conclusion. Integrating Python with C++ allows you to leverage the strengths of both languages. By understanding the Python C API and following the steps to embed or extend Python, you can create powerful and efficient applications. This integration opens up new possibilities